In this lesson, we are looking at question 31 of HSC Mathematics Advanced 2020 paper. The population of mice on an island, on an isolated island, can be modeled by the function m of t equal to a sine bracket pi on 26t close bracket plus e, where t is the time in weeks and the time is between 0 and 52, so that is in a year. The population of mice reaches a maximum of 35,000 when t is 13 and a minimum of 5,000 when t equals to 39. The graph of MT is shown. What are the values of A and B? Alright, based on what they have told us, we can say that this time is 13 and this time is 39 and the minimum is 5,000 and maximum is 35,000. We know that this function has an amplitude of A and has a mean value of B. So in other words, if I draw this line which constitutes the mean value for this cos function, that will be B. So B is the average of these two values. Then B is equal to 35,000 plus 5,000 all divided by 2, which gives us 20,000. That's the value of B. And for the value of A is the amplitude. So basically, how much is from B to 35,000 and how much is from B to 5,000. So A is then 20,000, take away 5,000. That is A equal to 15,000. So A came as 15,000 and B as 20,000. That was part A of this question. Part B, on the same island, the population of cats can be modeled by the function ct equal to minus 80 cos bracket pi on 26 bracket t minus 10 close bracket plus 120. Consider the graph of MT and the graph of CT. Find the value of T between 0 and 52 for which both populations are increasing. Alright, first we need to sketch this. From the previous part, we got to see between which values the population of mice is increasing. You can see it is from 0 to 13 and from 39 to 52. So for mice, we had population increasing when The time is between 0 and 13. And then between 39 and 52. I got to be careful with the equality sign because here it is stationary, so it's not increasing. So I should take the equality for 13 and also equality for 39. So you don't have this equality. All right, that is for mice. But for cats, we got to sketch it ourselves. So this is a cause function. First, we find its period. So period. So that is for cat. A period or t, I might use the term t. So t is equal to natural period for cos function, which is 2 pi, divided by the coefficient of t, which is pi on 26. If you divide this by that, you get 50. Alright, 52 is the period for this. And the amplitude for this is 80. And it is inverted because we have this negative. And shifted up by 120. So shifted up by 120. And shifted to the right by 10. Right by 10. Okay, I try to consider all of this into account, take all of this into account and sketch this. So that's the population of cats. The first thing is it is shifted up by 120, so I don't do it too scared, I just do this. That's my mean value, 120. Then it will go up and down by 80. And also shifted to the right by 10. All right, you know that a cos function in normal circumstances starts, if this is cos theta, and that is theta, starts from 1, goes to 0 at 90 or pi on 2, to minus 1 as 3 pi on 2, sorry, at pi, that's pi, and at 3 pi on 2 becomes 0, and at 2 pi becomes again 1. That's a regular cos. Now I'm inverting that, so if I invert that, it's going to be like this. I use a different color. If I invert that, that would be its reflection in the x-axis or theta-axis. That is minus cos theta. Then shifted up by 120, it means that I'm going to do, rather than using the x-axis, I'm using this line y equal to 120. And the amplitude is 80. The only thing is I need to shift also this by 10. So if this is 10, then I have this gone down by 80. So that means here I'm going to have 40. And my period is 52. So in one period I should have all my values and back to 40. So this will be 120 plus 80, which is 200, my maximum value. And you can extend this. And you know that this is 52 is my period. I started from here. 10 plus 52 comes as 62. And you know that we divide each period into 4 equal parts, and in each of them something important happens. Either your function hits the mean line, or becomes a maximum, or a minimum. So 52 divided by 4 is 13. Each one of these is 13. So 10 plus 13 is 23. And 23 plus 13 is 36. 36 and 13 is 49. And you can extend this a bit, but this is not important for us to speak, because we are talking about increasing. So as you can see, it increases for Mars. We have the increase from time greater than 10 and less than 36. All right. Now we want this to increase, and we want this to increase. And as you can see, for both of them to happen, your t must be greater than 10 and less than 30. That is the answer to this part. By combining this and this, we can see that t must be between 10 and 30. And part C, find the rate of change of the mice population when the cat population reaches a maximum. So, rate of the change of mice. So for mice, we had this. MT is equal to A, which was 15,000. So I write it on the next page. So we have MT equal to A, which was 15,000 times sine pi on 2060 plus B, which was 20,000. We want to find the rate of this. To find the rate, you differentiate with respect to time. Obviously, this is a constant, has a derivative of 0. For this one, derivative of sine is cos, and I've got 15,000 here, times by the coefficient of t, which is pi on 26, then times by cos pi on 26 as derivative of sine is cos. Alright, that is my derivative. But they want derivative at a certain time when the cat population reaches a maximum. That is the cat population, and it reaches a maximum when we have 36. So t is 36. So then m dash of t equal to 15,000 times by pi on 26 times by cos pi on 26 times by 36. So all we need to do is type this in your calculator, making sure that your calculator is on radians mode, and that will be whatever you get from here is the answer for this part of the question. Thank you very much for your attention.